What's up, YouTube? Adam here. Today we're going to be talking about bash scripting. We got a lot to cover, so I'm just going to go ahead and get started. So first thing you want to do is head over to Stack Overflow. And if you're not aware of what Stack Overflow, it is the largest, most trusted online community for developers. So it's the top link here on Google. Now when you get to Google, you may be tempted to say, I'm going to search for bash, but that, while it'll get you to resources, the best place to go is tags. So if you click on tags, you can filter by name, and we'll just type in bash, and we can see it brings it up right here. So if you click that link, it brings you to questions tagged bash. But here is where the real meat and potatoes are. Learn more. So if you click on learn more, it takes you to this whole tag info page, and it has notes regarding bash, a brief history, how to ask proper questions on Stack Overflow, common mistakes, and it's just overall a great resource. Whenever I'm learning a new programming language, I like to head down here to books and resources, and so a lot of these are free. Some of them may not be, but bash has got a lot of great free resources out there, so I definitely encourage you to check that out. Additionally, I'll be posting a link to some additional resources such as the Unix philosophy. Bash and Unix go hand in hand, so knowing some Unix philosophy definitely complements your ability to hack up some bash. We already talked about Stack Overflow and Explain Shell. If you're a complete beginner, I recommend heading to Explain Shell. If there's anything on this video that confuses you or that you don't understand. Other resources or practice here, there's HackerRank and there's Over the Wire Bandit. I would encourage you, if you're completely new, to start with the HackerRank shell, and then after you've worked through this tutorial, head over to Over the Wire and play the Bandit war game. That's actually really fun, and it really helps you apply what you've learned about bash scripting. So I'll be posting these links in my show notes. So this video is not intended to be an exhaustive reference. Concepts presented here are intended to serve as, a foundation to approach more advanced shell scripting topics. So let's get to it. Let's open a new terminal, and you see I have one here, and we're running bash, and I'm in an empty directory. So the first thing you usually do in any programming language is you run hello world to just see how you build an environment and how you print a standard out. So in bash, that's super easy. You just type echo and then what you want to say. So we'll say hello world. So what's really great about working in the terminal is we have our manual for just about all the built-in tools for bash. So if we want to look at the manual for echo, we just type man echo. So here we can see it's a BSD Berkeley software distribution general command, and it tells you all about it. I'm not going to read it to you verbose. You can check it out when you have some time. What's even interesting is even man has a man page. Man, format and display an online manual page. So now let's talk about variables. So we'll just start out with a simple example. Say foo equals fox. So then it, just like echoing text to console with hello world, we'll type echo foo. But you can see it just typed out foo. It doesn't actually put out fox, and that's because in bash you need the $sign in front of your variable, and then we can see it puts it out fox. If you want an empty variable, you can just hit enter, and we can give it a test here. And you see the empty variable, it's the variable. So you can concatenate strings onto one another and then build a longer string. So let's do that here. Foo, which we know is the fox, we'll change that to the quick brown foo. And then we'll echo foo, the quick brown fox. If you want to use multi-line values, you can do that. And here we can say the quick brown fox, new line, jumped over the fence. And that's because I used the \n. So now let's talk about file systems navigation. So if you type pwd, which stands for present working directory, we can see I'm in a path users, atom, projects, bash, guide. And so these are all directories or folders as you would call them in Windows. And guide is the directory that we're currently working in. So ls lists the files in our current working directory, and as you can see we don't have any. So if you type ls tac a, we can see a dot and a dot dot. So what are these? If you type file, it'll tell you what type of file you're working with. So file dot, we can see it's a directory. If we type file dot dot, we can see that is also a directory. And so these directories link to the parent directory and this current directory. So you can change directories using cd. So if you type cd dot, we're changing directories to this directory. And so if that sounds a little redundant, it kind of is, but it comes in very useful when you get to some more advanced concepts. So let's change to the directory above. You do that by doing cd dot dot. And now if you type pwd, you can see present working directory is now up one level from guide. Now we're back in bash. If you type cd with no arguments, it'll take you to your home directory. So if you print working directory, we're all the way in users atoms, and users and then your name is typically your home directory. You can change your directory back to the one you were working at by typing cd and then tac or dash. And so if you print working directory, you can see we're back in bash. So let's get back to our bash guide. So now that we've talked about how to navigate directories, let's make a directory. So making a directory is as simple as it sounds. Make dir, and then the name of the directory. We'll make a directory called folder. And if you run file on folder, you can see it is in fact a directory. If you want to know more things about a file, you can type stat, and then I like to use X for human readable output, and then folder. And you see it gives you the size, mode, permissions, effective user, and the access, modify, and change dates. Another way to get to this information for every file in the directory is to type ls tac l. And we only have the one folder, but it kind of condenses the information into a single line. So now that we've created that folder, let's just go ahead and change directories into it. Cd folder. So now that we've changed into our folder, let's create an empty file. You can create an empty file using touch and then the file name. So we'll say f1.txt, and we'll ls to see the contents of a directory. When we see we finally have something in our directory, we have f1.txt. And again, let's do ls tac a. You can see in this directory and the previous directory. And if you do ls tac la, you can see a more verbose information about the file. So if we say file f1.txt, we say it's empty. And similarly, stat works on files just as well as it works on directories. So now that we know about files, directories, and navigating directories, let's do some input output. We'll do echo and back again. And so if we just hit enter now, we've seen that that'll just go straight to the standard out on the console, and we'll see it here. But if we want to save it to a file, we can redirect it this way. We can type greater than f1.txt, and what that does is that sends and back again to f1.txt. So to concatenate and print files, there's a utility called cat. So we'll use cat f1.txt, and we can see it prints the contents of f1.txt to standard out. If we run file on f1 now, we can see that it's not empty, it has ASCII text in it. So what if we wanted to save other stuff to f1.txt? Well, if we typed echo foo, which we know is the quick brown fox jumped over the fence, we send that to f1.txt with redirection, and now we cat f1.txt. You can see it's in there. The quick brown fox jumped over the fence, but we're missing and back again. This is what's known as clobbering. It's effectively overriding the file. So if you want to append text to the file using greater than, as seen here. So now when we cat f1.txt, we can see it's all there. The quick brown fox jumped over the fence and back again. If you use cat with no parameters, or go cat and then hit enter, it reads from standard in. So ba ba black sheep. And so you can see cat empties standard in to standard out whenever you hit return. So you can hit Control and C, and that will stop reading standard input from cat. Another way to do this is to use cat and then tack or dash, and it's effectively the same thing. Ba ba black sheep. Have ye any wool? So more or less to kind of make sense of what cat is doing. And this is an oversimplification. It says while read line do, and then we echo that line for each line in the file. And that's it. It's an oversimplification, but you can see it's effectively the same. So if you want to intentionally clobber a file just to kind of empty it out, there's a couple tricks. You can do echo n into f1.txt, and if you cat it, you can see it's empty. So sometimes you'll run into a problem that there'll be way too much text in the file for it to dump to standard out. So let's just go ahead and make an example of that. So you can say for x in 1 to 1,000 do, and we'll just echo x to f1.txt done. So now when you do cat f1.txt, you can see it just dumps all this output to standard out, and it drops us off here at the 1,000. But if we're only interested in the first 100 values, this doesn't really help us. So you say, well, I'll just scroll back up. Sometimes your terminal won't be able to save all of the output, and you'll end up stopping. Like you would scroll up as fast as you can, and this would be as far as you could go. So the way around that is more, less, head, and tail. And we'll talk about those right now. So we already talked about redirecting F1. If we redirect it this way, it brings up, and we start here at the top. So you can see here at the very top we have 1, and then it goes all the way down. And so you can navigate this with J and K to go up and down line by line, or you can hit the space bar to do pages. But this makes it a lot easier to view a large file from the console. If you weren't necessarily interested in traversing through all the contents of the file, another thing you could do is you could use head. So head f1.txt, and we can see it prints out the first 10 lines of f1.txt. I bet you couldn't guess, but tail does the exact same thing, but from the bottom of the file. So it by default prints the last 10 lines of a file. If you only wanted the first 5 lines, you can add a flag in here, tack n, and then the number of lines you want. So if we only wanted the first 5 lines, you would put 5. Something I like to do is just, you can completely get rid of the n and put tack 5, and it knows that's how many lines you want. If you want the first 5 bytes of a file, you can type tack C and then 5, and we can see we get our 5 bytes. We get 1, 2, 3, and a new line character, and so on. So these flags work a lot the same way with tails. So tail 5 f1.txt, and we get the last 5 lines of f1. So now let's start talking about calculations. Now bash isn't exactly the greatest for calculations. It can do them, but if you're doing something that's computationally intensive, recommend using a different language. So if you wanted to write some script that gives you all the odd numbers between 1 and 10, here's how you do it. For x in 1 to 10, and we kind of saw this already when we pumped 1,000 numbers into f1.txt, but you can do your step here at the end of the brackets. So this starts at 1, and then it goes 3, 5, 9. So do echo x done. 13579. So if you wanted to do the reverse even, one thing you could do is you could say 0 through 9 and use a negative step. So that's how for loops and stepping work. So now that we know how to loop and do variables, let's calculate the factorial of 4. So we'll start out with fact equal 1 and then for x in, and we're going 1 to 4 do. And so here's how you can do math in the shell. If you use $ when you're trying to do math, it doesn't work appropriately. So you want to do double paren fact times equals x. And again, you don't want to use the $ in here when you're doing the math. And then you say done. You have to do echo fact, and we see it's 24, which is what we expected.